Hi, my name's Jamie Davis, and I'm going to be discussing Android code obfuscation, what it is, why it's necessary, what tools are available to perform obfuscation, as well as what specific methods are utilized in the obfuscation process. First, we're going to start by talking about what Android code obfuscation is. It works to alter the Java and Android application source code in order to protect against reverse engineering and the altering of the code by hackers. Why is it necessary? Since Java and Android code are compiled into bytecode, which has a vulnerability of being reverse engineered, the reason for this is because the bytecode contains a significant amount of the same information as the original source code. So the structure field, method, property, and parameter names are all maintained from the original code to the bytecode. This can be convenient and helpful for programmers that are attempting to debug a program that they don't have access to the source code. However, that convenience for programmers can be a huge drawback for those with less innocent intentions. The attackers could gain access to algorithms and logic that could easily lead to the revealing of passwords and pins, or at least the methods that are used to create them. So what methods are used? Obfuscation is done using a number of methods and techniques, but most commonly it's done by changing the meaningful identifiers that programs have chosen to help them understand and easily identify the various items within the program. The names are changed from those meaningful IDs to something less meaningful, like a random string, typically no more than 3 characters in length, and obviously depending on the program, of course, those could be longer at any point in time. So what you'll notice in the picture that I've shown is on the left-hand side, you're going to see the original source code with the meaningful names of test 1, term 1, which the programmer would understand and utilize. And then if we look at the obfuscated code on the right-hand side, you're going to notice that, again, meaningless characters like the letters A, B, and C, they're hard to reverse engineer and trace back to understand the logic behind it. Another method that's used within the obfuscation process is control flow obfuscation. This works by changing and modifying the logical flow of the program. It can be done by inserting code that has no relevance, changing looping conditions to increase the loop iterations, or even adding repeated code to make it redundant and confusing for somebody who's going to reverse engineer this program. That technique falls under the category that's considered being to flatten the code. It makes it more costly to reverse engineer. Flattening the code takes away from the traditional top-down design used in programming and runs the program from a function somewhere embedded within the center of the code. This kind of gives an idea of this spaghetti logic, which makes the decompiled code have multiple interconnecting logics that are extremely hard, if not impossible, for hackers to follow and comprehend. The programming is only modified to a certain degree, so the result of the program executing is not altered, but decompiling it into a Java program for a hacker to understand is next to impossible. So this spaghetti logic takes and it continuously loops so that as the hacker is then trying to follow that flow, it takes them into this completely illogical pattern and loop that makes no sense. There are some other methods used as well. We've looked in detail at 2 of the main methods within the obfuscation process, but there are certainly others. Some of those include string encryption, instruction pattern transformation, dummy code insertion, unused code and metadata removal, which that one's more of like an optimization tool, which I'll talk about in a moment. That optimization can also help to protect against reverse engineering by making the size of the code smaller, which results then in less code being available during the reverse engineering process, thus less information available to hackers. So with those being the methods, it's important that we discuss some of the tools that are available for programmers and developers to use in the obfuscation process. The first tool that I'll talk about is going to be Proguard. It's the most popular tool being used for Java code optimization, but it's also extremely useful for the obfuscation. Not only is it effective, one of the main appeals of using Proguard for obfuscation of Android code is the fact that it's free to its users. The tool will run during the compiling stage of your code and work to not only obfuscate, but also shrink and optimize the code in order to make reverse engineering significantly more challenging, as we previously discussed. Traditional obfuscation within Proguard will alter the line numbers, file names, and methods, which makes any error stack traces virtually useless and impossible for hackers. Another advantage of using this tool is the ability of the user to choose the default settings and use Proguard configuration files to control exactly how you'd like the obfuscation to execute. So it's customizable based on what your goals are. The next tool that we'll talk about is -O. This is a tool used for obfuscation of Java and Android code as well, but it provides other functionalities. There's layered obfuscation, anti-tampering, anti-debug, watermarking, encryption, and anti-hooking, just to name some of the offerings provided. Securing your program code can happen without sacrificing the runtime and performance of your program, and without the cost of a programmer working extra hours to secure. And that's one of the components that -O brags upon. It's not offered as a free service, however. Instead, you are required to submit a request to -O, and their sales team will then package their services, which are available on a subscription basis based on the needs of your program. With that subscription, you're given 24-hour software support by a highly qualified professional team. The next tool we'll talk about is the Aleatory. Aleatory is a full-service obfuscator that will provide protection for your source code and programs. This is a second-generation offering, which they brag on its additional functions as compared to its competition, going as far as stating that Aleatory makes reverse engineering next to impossible for hackers to perform. Aleatory is offered as a commercial or individual service. It can be purchased using licensing. A single developer license will allow exactly one individual access to all of the Aleatory files necessary for that person and their project. The license purchase also comes with free email support and any updates that occur within the subscription time of 12 months. The single developer license costs currently $75. And then you can also get site licenses and business licenses, and they are $500 and $750 respectively. In addition to the features that you would get with the individual developer license, both the commercial license and the site license offer some additional features. They allow permission to share or use all of the files concurrently by any number of developers within the company. The only restriction to that would be for the site license. It'd have to take place within a single physical location as defined by your agreement. There are some exceptions to that rule, but again, that would be something that you would have to discuss within your agreement. And the business license then permits users all around the world to access those files and share them concurrently. There are other obfuscation tools that are out there and available. DexGuard is another one. It offers a number of features and upgrades so that companies can customize their software package. DexGuard is the commercial version of Proguard. There's also IXGuard. It's not used for Android and Java code, but I felt like it was important to mention that this tool is available for iOS applications. And so any developers using Swift or Objective-C could utilize this tool to protect their intellectual property from attackers. YGuard, another downloadable program that offers many useful tactics in order to secure source codes. Most notably, it's free, so that's definitely very popular for users. Now that we've kind of talked about the methods and tools that are used to obfuscate, it's important to discuss when it's necessary to obfuscate and for what purpose. Developers should be using obfuscation to some degree at least in any situation where they're developing valuable software that will be used outside of their immediate possession, and they have no intention of releasing the source code. In conclusion, What we've looked at is that Java and Android applications are prone to reverse engineering and malicious attacks because they use bytecode, which maintains many of the constructs of the original code. Reverse engineering is one of the main threats to this source code, and the code is being compromised, it's being altered, things added or taken away from it. So obfuscation is used to make changes to the code and the logical constructs and naming to provide security and protection against this threat. We've also looked at the tools that are available for obfuscation. There's a limited number, but each is designed to obfuscate a specific programming language or multiple languages based on what tool it is that you're looking at. And then these tools are available for both individuals as well as businesses to utilize in securing their source code.